The story of our planet is written in stone, a vast and silent library of epochs and ages. We, in our fleeting moment of existence, have learned to read its pages. We have found the petrified bones of colossal beasts that roamed continents long before our own, the fossilized imprints of primeval forests, and the chemical traces of atmospheres alien to our lungs. In all this immense history, stretching back 4.5 billion years, our own story, the story of Homo sapiens, occupies only the final, thinnest paragraph. We have built cities of glass and steel, split the atom, and cast our thoughts across the void on electromagnetic waves. We consider ourselves the Earth's first and only technologically advanced species. But what if we are wrong? What if, in the deep, unread chapters of Earth's biography, another story lies hidden, the story of a civilization that rose, flourished, and vanished millions of years before the first hominid ever walked the African savanna? This is not a question of sunken cities like Atlantis or mythical continents like Lemuria. Those are human legends, rooted in human timescales of thousands of years. We are asking a much more profound and disturbing question. Could an industrial civilization, with its own cities, its own industries, its own global impact, have existed, say, 60 million years ago, only to be completely erased by the relentless churn of geological time? This thought experiment is known as the Silurian hypothesis, a name playfully borrowed from a classic episode of Doctor Who, but its implications are deadly serious. It forces us to confront the true nature of evidence and the sheer, humbling scale of deep time. Imagine you are a geologist 100 million years from now. You are studying the rock layers corresponding to our present day, a sliver of sediment known as the Anthropocene. What would you find? The ruins of New York or Beijing would be long gone. Tectonic subduction, erosion, and sedimentation would have ground our proudest monuments to dust and buried them miles beneath the surface. Steel would have oxidized into rust streaks in the rock. Glass would have reverted to sand. The chances of finding a fossilized human skeleton are infinitesimally small. Fossilization is an exceptionally rare event requiring perfect conditions. Less than 1% of all species that have ever lived are known to us through fossils. An urban, tool-wielding species might leave even fewer conventional traces. So, if not our bones or our buildings, what would our true legacy be? What is the indelible signature of an industrial civilization? It is not solid, but chemical. It is not local, but global. Our civilization is powered by burning fossil fuels, the compressed remains of ancient life. This process unleashes vast quantities of carbon into the atmosphere. Crucially, this carbon has a specific isotopic signature. Carbon from ancient plants is lighter, depleted in the carbon-13 isotope compared to the carbon that cycles naturally in the atmosphere. A future geologist, analyzing the carbon isotopes in the rock strata of our era, would see a massive, abrupt spike in light carbon, a planetary signal that screams of something unnatural. Our fingerprint would be written in other elements, too. To feed billions, we invented the Haber-Bosch process, pulling nitrogen from the air to create fertilizer on an industrial scale. This has fundamentally altered the planet's nitrogen cycle, and this too would leave a distinct isotopic trace in the sediments. Then there are our creations that nature never conceived, plastics. These persistent organic pollutants would degrade over millennia, but their unique molecular fossils, or technofossils, could be preserved in the rock, perhaps even forming new types of stone like the plastiglomerates already found on our beaches today. We have created synthetic compounds like PCBs and CFCs, which will linger for geological ages. And most chillingly, we have harnessed the power of the atom, the long-lived radioactive isotopes from nuclear weapons testing and reactor waste, such as plutonium-239, are markers with no natural equivalent on Earth. Their presence in a thin sedimentary layer would be a smoking gun, an undeniable sign of advanced technology. Finally, an industrial civilization, by its very nature, reshapes the biosphere. We are currently presiding over the sixth mass extinction event in Earth's history. The sheer rate of species loss is comparable to the cataclysms that wiped out the dinosaurs. A future paleontologist would notice a sudden, dramatic disappearance of countless species in the rock record, coinciding precisely with the strange chemical spikes of carbon, nitrogen, and synthetic elements. This, then, is the true calling card of a technological species, a global geochemical scar. It is a fundamental change in the planet's metabolism. So, the Silurian hypothesis poses a simple, elegant question. Have we ever found a scar like this before in the geological record? With this new searching engine mind, we can scan the Earth's deep history, and we find something. Around 56 million years ago, at the boundary between the Paleocene and Eocene epochs, our planet experienced a dramatic and mysterious event. It is called the Paleocene-Eocene thermal maximum, or PETM. Over a period of a few thousand years, a blink of an eye in geological terms, the Earth's temperature soared by 5 to 8 degrees Celsius. The oceans acidified rapidly. A mass extinction event occurred, particularly affecting deep-sea organisms. And at the heart of it all was a massive injection of carbon into the atmosphere, an injection whose isotopic signature looks eerily, hauntingly familiar. It was a huge spike of light, carbon-13 depleted carbon, precisely the kind of sigma we are creating today. The PETM is one of the most studied and profound climate events of the last 66 million years. For a moment, the parallels to our own Anthropocene are uncanny. A rapid warming event, ocean acidification, mass extinctions, all driven by a colossal burst of carbon. Could this be it, the ghost of a long-lost industrial world? Could a civilization of, perhaps, hyper-intelligent reptiles or mammals have risen in the lush, hothouse world of the Paleocene, discovered its own form of fossil fuels buried beneath its feet, and burned through its inheritance in a geological instant? The idea is intoxicating. It fires the imagination with visions of saurian cities nestled in fern-choked jungles, of strange vessels plying the warm, acidic seas. But science demands rigor, not romance. When we examine the PET more closely, the narrative begins to fray. The timescale, for one, is a problem. While rapid geologically, the carbon release during the PETM seems to have occurred over several thousand years. Our current carbon emission is an order of magnitude faster, a near instantaneous shock to the system. The ancient event was a high-speed planetary fever. Ours is a planetary heart attack. Furthermore, the isotopic evidence, while similar, is not identical. The specific ratio of carbon isotopes during the PETM can be explained by several natural phenomena. The leading theories point to massive volcanic eruptions cooking organic-rich sediments, or a sudden, catastrophic release of frozen methane hydrates from the seabed. Methane is a potent greenhouse gas, and its carbon is also isotopically light. While these natural causes are themselves immense and terrifying, they do not require the hand of an intelligent species. And then there is the most compelling argument against a pre-human civilization, the resounding silence of all other evidence. While we acknowledge that buildings and tools would not survive, an industrial civilization does more than just burn fuel. It mines, it processes, it concentrates materials in unnatural ways. We would expect to find strange sedimentary layers enriched with unusual metals, the fossilized remnants of their landfills and industrial sites. We would expect to see unusual concentrations of rare earth elements or strange metallic spherules from their smelting operations. We might even find a single and ambiguously artificial object, a technofossil so strange it defies natural explanation. Yet, in the meticulously studied rock layers of the Penton, and indeed across the entire geological record, we find nothing of the sort. The Earth's library contains no such chapter. The silence is absolute. So, the likely answer to our question is no. The evidence strongly suggests we are the first species on this planet to build a global, energy-intensive technological society. The PTM was likely a natural convulsion of the Earth's climate system, a warning of what the planet is capable of, but not the echo of a forgotten peer. But the value of the Silurian hypothesis is not whether it is proven true. Its true power is that it acts as a mirror, by forcing us to imagine how we would detect a vanished civilization. It compels us to see our own in a terrifying new light. It reframes our existence not as a cultural or historical phenomenon, but as a geological one. We are no longer just building cities and writing poems. We are actively changing the chemistry of the planet on a scale commensurate with asteroids and supervolcanoes. Our legacy, the signal that will outlast our languages, our art, and our memories, is being written right now in the air, the oceans, and the ice caps. It is a story of displaced carbon, of synthetic polymers, of rearranged nitrogen, and of species vanishing forever. We are creating the very evidence that a future intelligence, whether it evolves on Earth millions of years from now or arrives from the stars, would search for. The thought experiment reveals a profound irony. For decades, we have sent messages into space, like the golden records aboard the Voyager probes, hoping to announce our existence to the cosmos. We imagine our legacy as one of intelligence and achievement. But the Silurian hypothesis suggests our most enduring and unambiguous message will not be sent outward to the stars, but downward into the rock. It will not be a record of our music or our mathematics, but a chemical scar, a planetary wound, a thin dark line in the strata of the Earth that says, for a brief, brilliant, and perhaps reckless moment, we were here. The question is not whether there was a civilization before us. The question is how long ours will last, and what story the rocks will tell about us when we too are gone.